Hello everyone. This video would focus on conic section, specifically on ellipse that has a center at the point of origin or 0, 0, and this is the first part. This part will show how to determine the case number, the center, the foci, the vertices, the co-vertices of a given equation of an ellipse. Before we go over this example, let's have a review on the parts and the two cases of an ellipse with a center at the point of origin or at 0, 0. We remember that there are two cases of an ellipse. The first case here is the horizontal ellipse. Before we go over this case, let's have the parts of every ellipse. The first part that we have here is the center. The center is halfway between the two diameters of the ellipse. The second part that we have here is the major axis. The major axis is the longer diameter of an ellipse that connects the two vertices passing through the center. So this means that both of these two dots that we have at the end of the major axis are the vertices. So one is the vertex and the other is the other vertex. The plural for that is vertices. So pretty much vertex is the end point of the major axis. Now we also have another diameter which we call as the minor axis. This is the shorter diameter of an ellipse that connects the two co-vertices of an ellipse passing through the center. So this point right here is a co-vertex of an ellipse, and this point down here is also a co-vertex of an ellipse. The next part of an ellipse is focus. So these 2 points right here are the focus of the ellipse. The plural for focus is foci. This focus is always gonna lie along the major axis. Please remember that foci of an ellipse are two fixed points on its major axis such that the sum of the distance of any point on the ellipse from those 2 points is constant. So those are the basic parts of an ellipse. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis. So that means this runs from the center to the vertex, and we are going to represent this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, meaning this connects the center to one of the co-vertices. And this line segment from the center to the co-vertex is represented as letter B. Now, on the other hand, from the center to the focus is represented as letter C. Now, using these letters A and B, we can derive the equation of a horizontal ellipse. Now, using these lengths A and B, we can come up with an equation of a horizontal ellipse, and that is x squared over a squared plus y squared over b squared is equal to 1. Now, notice that our A is the longer value, because this is actually half of the major axis, which is the longer diameter. Now, notice that our A, which is the longer value, is the denominator of x squared. This means that if the denominator of x squared is bigger compared to that of the denominator of y squared, that means that we can come up with a horizontal ellipse. Now, we also remember that our A value, which is the semi-major axis, will always be greater than B, which is the semi-minor axis. That's always every time. And the equation that can be used to determine the length of C, that is from the center to the focus, is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. For the second case of an ellipse, we pretty much have the same parts. The first part is the center. Again, this is halfway between the two diameters of an ellipse. We also have a major axis. This is the longer diameter of an ellipse that connects the two vertices passing through the center. Now, please notice that we call this as a vertical ellipse because the major axis is the vertical line segment. We also have the parts which we call as the vertex. There are two of them. We call them as the two vertices. These are the two endpoints of the major axis. We also have a minor axis that is the shorter diameter of an ellipse that passes through the center and that connects the two co-vertices. And again, on this, along this minor axis, we have the co-vertices or the co-vertex if it's singular. These are the endpoints of the minor axis. Now we also have another part which we call as focus. So these 2 points right here are our foci. So pretty much these are the parts of an ellipse. So it doesn't really matter if it's a vertical ellipse or a horizontal ellipse. The parts would still be the same. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis, which means this connects the center to the vertex. And we are going to label this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, which means this connects the center to the co-vertex or one of the co-vertices. And we're going to label this as our B. Now, we also remember that the distance from the center to the focus is represented as letter C. Now, using these lengths A and B, we can therefore say that our equation for a vertical ellipse is x squared over b squared plus y squared over a squared is equal to 1. Now, notice that our a squared is under the y squared. This means that if the value under or if the denominator under the y squared is bigger than the denominator under the x squared, we are able to get a vertical ellipse. And we also remember that again, our A is always greater than B. Now to determine the length of C, we are going to use the equation C squared equals A squared minus B squared. So these are the parts of an ellipse, and these are the two cases of an ellipse. Now let's go back to the problem. Okay, we're given x squared over 49 plus y squared over 16 is equal to 1. We're supposed to determine what case is this. In order that we can do that, we look at the number in the denominator. So we have a 49 and we have a 16. Comparing these two values, 49 is bigger than 16. This means that whatever the bigger value is, we take that as our letter A. And whatever is the smaller value, we take that as letter B. So in this case right here, we will take then 49 as our A squared and the 16 as our B squared. Now looking at this value, this 49 is under the x squared. So it's the denominator of x squared. This means that this is an example of a horizontal ellipse. I'm going to write that down here. Okay, the reason why this is a horizontal ellipse case, it's because the bigger number or the bigger denominator is under the x. And remember, x is either left or right. And so it's a horizontal ellipse. Now, if the denominator under the y was bigger, then it would have been a vertical ellipse. But for this case right here, we have a horizontal ellipse. The center is at 0, 0. So I'm going to write that down here. So the center is at 0, 0 or at the point of origin. Now we are supposed to solve for A. In order that we can do that, we equal this 49 to A. So I'm going to write that down here. So that is A squared is equal to 49. So solving for A is actually plus minus 7. We square root both sides of this. So A squared square root, 49 square root would be plus minus 7. To solve for B, it's the same thing. We are going to write this down. B squared is equal to 16. And so our B value is plus minus 4. Now we remember that A is the distance from the center to the vertex and B is the distance from the center to the co-vertex. So I'm going to write that down here. Okay, so what are we going to do is that we have a center at 0, 0. So I'm going to label that as letter C. Now, we say that the A is 7. So that's the distance from the center to the vertex. So we're going to count 7 to the left and 7 to the right. So that's 1, 2, 3, 4, 5, 6, 7. So this will be our vertex, and the other vertex is also across here. I'm going to label that as letter V. Since we already have the two vertices here, I'm going to write the coordinate of these two vertices up here. Now, to find the co-vertices, remember that the letter B is the measure from the center to the co-vertex. It's going to go up and down 4. So that's 1, 2, 3, 4. So that's the co-vertex. And 1, 2, 3, 4. This is another co-vertex. So we can therefore write the coordinate of these two co-vertices up here. So that from here, we can go ahead and sketch the ellipse. Now, to find the coordinate of the two foci, we remember that the distance from the center to where the focus is represented as letter C. So I'm going to show the work on the side right here. Okay, so what I did here was I solved for C. Now again, we remember that C is the distance from the center to the focus. So we can go ahead and say that the distance from the center to one of the foci is 5.74. By the way, we are going to go to the left and right as well for the focus, because remember that the focus is located on the major axis. So it's gonna go towards where the vertex is. So that's 1, 2, 3, 4, 5.74. So that should be somewhere around here. So this is our first focus, and the other focus would be across. That's 5.74 should be somewhere around here, and this is the other focus. So then the coordinate for this two foci can be written up here. Okay, so we have graphed this given equation that we have here, and we have determined which case number this is. We determined the center, the two foci, the two vertices, and the co-vertices. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, pause it and check your answer. Okay, so we go over the problem here. Again, to determine what case number this is, we'll look at the value on the denominator of both x squared and y squared. We see that 64 is a bigger value than 25, so that we can go ahead and say that this is actually our a squared. And so that means that this 25 is our b squared. Since our a squared, or the bigger value, is under the y, we can go ahead and say that our y again is either up and down. So then we say that this is a vertical ellipse. I'm going to write it down here. Okay, we can also say that the center for this ellipse is at 0, 0, or at the point of origin. So I'm going to write that down here. That's 0, 0. So we can go ahead and plot that center right here at 0, 0. Now we are going to solve for A. So I'm going to show that work on the side right here. Okay, so we have solved both A and B. I just got the square root of 64, that's plus minus 8, and the square root of 25, that's plus minus 5. We remember that A is the distance from the center to the vertex, and B is the distance from the center to the co-vertex. So I'm going to label that down here. Okay, since we have already the values for A and B, and we remember that this is a vertical ellipse, so this A is going to go up and down 8 from the center. So I go up 8 and down 8. Okay, so I've labeled the two vertices, and I'm going to write the coordinate of these two values up here. Now we are going to determine the co-vertices. Now remember that the co-vertices is represented as letter B, and we have a 5 here, so we go left, right, 5. Okay, so then we are ready to sketch the graph of this ellipse right here. Okay, now let's determine the location of the focus. Now we remember that one focus is located at the distance C from the center. And so I'm going to show the work to determine the C here. Okay, so the location of the focus is plus minus square root of 39 or approximately 6.24. So I go up 6.24, go down 6.24 to determine the location of the focus. So we have graphed the equation of this ellipse that we have right here, and we have determined the case, the center, the foci, the two vertices, and the two co-vertices of this equation that we have up here. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!